2019, AMC 12, problem 21. Let z be 1 plus I over root 2. What is the sum of z to the k squared for k from 1 to 12 times the same sum built from 1 over z? 5 choices from 18 up to 72 plus 36 root 2. Before we solve anything, read like a detective. Observation 1. Z is a very deliberate number, 1 plus I over root 2. Numbers like that are chosen for a reason. Observation 2. The exponents. 1 squared, 2 squared, 3 squared, perfect squares, all the way to 12 squared. And observation 3. The answer choices. Look closely. Every single one is real. No I anywhere. So whatever mess happens in the middle, the imaginary parts must cancel by the end. That's our compass. No fear. Let's go. First, who is z? Put on a picture. Check its size. The length of 1 plus I is root 2. Divided by root 2, exactly 1. Remember this. Magnitude 1. It will pay us back at the very end. And its direction? 1 plus I points exactly northeast. 45 degrees. So z sits on the unit circle 1/8 of the way around. Now watch what powers of z do. Each multiplication turns the arrow by another 45 degrees. 2 steps, 90. 4 steps, 180. 8 steps, a full turn back to 1. Z to the 8th is 1. Sit with that. It changes everything. Only the exponent, mod 8, matters. So we only need k squared, mod 8. And when we hunt for a pattern, you know the move. Small cases. Let's build the table, k from 1 to 12. Square each k, reduce mod 8. 1, 4, 9, that's 1. 16, 0. 25, 1. 36, 4. 49, 1. 64, 0. And the last 4 sing the same song again. 1, 4, 1, 0. Now stare at that bottom row. 3 families. Odd k, always 1. K equals 2, 6, 10, 4. And k equals 4, 8, 12, 0. That odd family carries the whole problem. So let's check it, not trust it. Any odd number is 2m plus 1. Square it. 4m squared plus 4m plus 1. Group the first 2. For times, m times m plus 1 plus 1. But m and m plus 1 are consecutive. One of them must be even. So this bracket is 4 times an even number, a multiple of 8. Try it. M equals 1. 3 squared is 9. 8 plus 1. M equals 2. 5 squared, 25. 3 eighths plus 1. Every odd square is 1 more than a multiple of 8. The pattern is real. Back to the table. Count our 12 k's. 6 odd, 6 copies of z. 2, 6, 10, 3 copies of z to the 4th. 4, 8, 12, 3 copies of z to the 0, which is just 1. And what is z to the 4th? Watch the arrow. For steps of 45 degrees, a half turn, straight across the circle. Minus 1. Log it next to our count. Name the first factor S1. That's the whole first sum, all 12 powers of z. By our count, it is 6 copies of z, plus 3 minus 1s, plus 3 plus 1s. And the 3's annihilate each other. S1 is just 6z. Now the second factor. Call it S2. Same exponents, but built from 1 over z. Do we grind through all of that again? We do not. Remember the magnitude 1 we filed away at the start? On the unit circle, 1 over z is z bar, the conjugate. The same picture, flipped. So the whole S1 story replays word for word, and S2 collapses to 6z bar. Look back at what the problem actually asked for. The first big sum times the second big sum. That is exactly S1 times S2. 6z times 6z bar. 36 times z bar. And z times its own conjugate is the magnitude squared. So this is 36 times 1, which equals 36. The eyes are gone, exactly as the answer choices promised. 24 scary powers of Z. One clean, real number. Quick replay, 10 seconds. Z lives on the unit circle, and Z to the 8th is 1. So only k squared mod 8 matters. And the table gave just 3 families. They collapse the first sum to 6z, the second to 6z bar. Multiply, and you get 36 times the magnitude squared, which equals 36. Back to the problem we started from. There it is, 36. Choice C, and we're done.